Hey guys, Mr. Ground here with 6.5 day real roots of polynomials. Only one day of this. I forgot to take that out. What we're doing today, solving polynomials by factoring. We're going to learn about what multiplicity is and how to identify the multiplicity of solutions, and then also writing polynomials based on known solutions, which is basically solving polynomials by factoring except in reverse. Okay, so how would we solve this? This is essentially what we are focused on with 6.5 and 6.6. How do I solve when a polynomial is equal to 0? We've got a few options here. One of them that you did in Algebra 2, and we will use this, but not today, is to graph it. If you graph this, if you plug this into Desmos or into your calculator, you would get a parabola that looks like this, and you could figure out that where it crosses the x-axis, that's where this graph is equal to 0. That's where the equation is equal to 0, is where the graph crosses there. And that would be at positive 2 and positive 4, so 2 and 4. That's a nice simple way to do it. We could also, in this case, use the quadratic formula. Quadratic formula, we would identify the coefficient of x squared is 1, the coefficient of x is -6, and the constant is 8, and then we would plug it into the quadratic formula. (b plus or minus square root of b squared minus 4ac all over 2a, which is 1 in this case. Now, we're not doing that in this. I'm just sort of trying to make a point here, so don't worry if you can't remember the quadratic formula. 6 plus or minus, all of this simplified is 4 over 2, and we've got then 6 plus or minus 2 over 2. 6 plus 2 is 8, divided by 2 is 4. That was one of our solutions. And 6 minus 2 is 4, divided by 2 is 2. So I came up with the same two solutions, 2 and 4. All right, so either of those works. What we're going to be focusing on is the third option here that is actually quicker if you know what you're doing. Factoring. So what is the factored form of this? X squared minus 6x plus 8. I want numbers that multiply to 8 but add to -6. So x minus 4 and x minus 2. Where does this equal 0? This equals 0 where either of these factors equals 0. If I solve x minus 4 equals 0, add 4 to both sides, and I get x is equal to positive 4. So that is one of my solutions. If I do the same thing with the other factor, x minus 2 equals 0, add 2 to both sides, and x equals 2. That's my other solution. So I came up with same three numbers, so I'm pretty confident that these are correct. So why is it that this has a solution at 4, this has a solution at 2? Why don't we plug it in just to see what happens? So if I plug in 4 into this equation, it is 4 minus 4 times 4 minus 2. Well, that's 0 times 2, which is 0. What happens then if I plug in 2? Same thing, only in reverse. 2 minus 4 times 2 minus 2. This ends up being -2. This one is still 0. -2 times 0 is still 0. So you don't have to worry as much about like the x value that makes the entire equation equal to 0. Whatever makes one part of the factored form equal to 0 is going to kill the whole thing, because 0 times anything is 0. All right. There is a property for this. It's called the zero product property, and it states this. Come on. If x minus a times x minus b is 0, then a and b are both solutions. And that's because those are the numbers that would make one of or the other factor equal to 0. And if one of them is equal to 0, then the whole thing is equal to 0. Now, that's nice and easy for these ones, like x plus a number, x minus a number. All you have to do is flip the sign. If it's a factor like this, what we can do is a little bit of basic algebra by setting that factor equal to 0. So let's say we've got something like this. We factor it out and it's x minus 1 times 2x minus 1, right? That equals 0. Well, I can just flip the sign here because 1 minus 1 is 0, so that's positive 1. And then this one, I can set that factor equal to 0 and then just do some two-sided equation algebra. Add 1 to both sides, 2x equals 1, divide both sides by 2, and I get x equals 1/2. So my two solutions for this particular one would be 1 and 1/2. One of them easy, I could just flip the sign. One of them a little tougher, I can do a little bit of algebra, but it's something we can all handle. Okay, if x is a factor, then 0 is automatically a solution. So let's say if instead of this, maybe we've got some GCF factoring, and we end up with x times x minus 1 equals 0. Well, I know that if x is 1, then it's going to be 1 times 1 minus 1, which is going to be 0. But also, if x is equal to 0, the whole thing will be equal to 0, because then it's 0. If I plug that in, it's 0 times 0 minus 1, which is 0 times negative 1, which equals 0. That's one that students a lot of times forget. It's like the really simple one that's like almost too simple where you screw it up. If x is, or x squared or x cubed is a factor where it's not plus or minus a number, that means 0 is automatically a solution. Now, speaking of solutions, we've got multiple names for our solutions now. We can also call them roots of a polynomial, zeros of a polynomial, or x-intercepts, especially if we're talking about it graphically. Okay, so let's do some of these. Solving these by factoring. This one, pretty straightforward factoring, sum and product. Two numbers that multiply to 6, add to 7 are plus 6 and plus 1. And so these ones are nice basic ones. I can just flip the sign. Negative 6 and negative 1. This one, difference of squares. Hopefully we all recognize it's plus 6 and minus 6. And then we can just flip the signs again. X equals negative 6 and positive 6. You could also do plus or like the plus minus symbol in 6, but if you're typing it into Canvas, I'm thinking that this is a better option. Okay, now these two, they're not equal to 0, so how do I approach this? Well, I approach this by making it equal to 0. Quadratics and polynomials are always easiest to solve if one side is equal to 0. So anything from here on out in Chapter 6, if it's not a 0 at one side, you got to make it 0 on that side. So subtract 40 from both sides, x squared minus 3x minus 40 equal to 0. Now I've got a factorable quadratic. Minus 8 and plus 5. And my solutions, these are nice ones because I can just flip the sign. I don't have to think about algebra really. Same thing with this one. It's not just a number on the other side like this. Doesn't matter. I can take that 6x and I can add it to both sides to move it over here. X squared plus 6x minus 27 equals 0. Now I've got something that factors. Plus 9 and minus 3. That's going to be true when x is equal to negative 9, so flip the sign, and positive 3, flip the sign there. All right, let's get into some tougher ones now. Oh, come on. There we go. So some voodoo factoring, right? We're going to start this out. Take the 3. Look for a GCF first. No GCF. I'm going to take the 3 and move it over to the 32, and that's going to make this x squared plus 28x plus 96. Factors of 96 that add up to 28. You might have to get your calculator out and start doing like 96 divided by 1, 96 divided by 2, 96 divided by 3 to figure out what the factor pair is. In this case, it's x plus 24 and x plus 4. Now I'm not done. The answers are not negative 24 and positive 4. I have to undo where I multiplied this 3, right? I didn't multiply 3 on both sides. I changed this equation. This is a different equation. So now I have to fix it by dividing the 3 to sort of make up for it. Okay, this one is x plus 8, 24 over 3. This one doesn't reduce, so we'll do 3x plus 4, like that. Now I've got two things here. X equals, okay, I'm going to put the answers over here. X equals, for this one I can just flip the sign, and it's negative 8. This one, I'm going to do a little bit of algebra. 3x plus 4 equals 0, minus 4, 3x equals negative 4. Divide both sides by 3, and I get that x is negative 4/3. So negative 8 and negative 4/3 are my solutions. My zeros, my roots of that one. All right. GCF here, right? X cubed, x squared, x. They all have an x with them, so I can factor out an x. And what's left is x squared minus 3x minus 40 still equal to 0. So I already know one of them is going to be 0 because x is a factor. And if I think about that on this one, right? This gets a 0, this gets a 0, this gets a 0. Every term is going to turn into 0 if x equals 0. Okay, so then this would factor to what? Minus 8 and plus 5. I almost said 3. And now I've got two nice ones where x minus 8, I just change the sign to a positive 8. X plus 5, I change it to a minus 5. All right, let's do two more tough ones. Ooh, so now some voodoo and some GCF, except it's not equal to 0 yet. I got a little bit of work to do first. Make this equal to 0. Plus 21 on both sides, and this is going to be 2x squared minus 13x plus 21 equals 0. Now I've got something that I can maybe solve through voodoo factoring. Bring the 2 over here. X squared minus 13x plus 42 equals 0. Factoring this, 42 is 6 and 7, so minus 6x minus 7, that works out. Then I'm going to divide by 2, right? I can't just solve this quite yet. I'm going to get rid of these equal zeros because I changed the equation, and now I'm changing it back. So I'm going to wait till I get to the end here. So x minus 3, and then this one doesn't reduce, 2x minus 7. So for my x's, may or may not live in Texas. X minus 3, that's 0 at positive 3. This one, I can solve algebraically. I'm going to move it over to the side here. 2x minus 7 equals 0. Add 7 to both sides. 2x equals 7 over 2, and x equals 7 over 2. So 3 and 7 over 2. Okay. Last one for this video. Another one where I need to start out by moving everything over to one side, so one side is equal to 0. And I get x cubed plus x squared minus 30x is equal to 0. Factor out an x. X times x squared plus x minus 30. X is a factor, so I already know 0 is going to be a solution. And again, if I go back to the original equation, 0 cubed plus 0 squared is 0. 30 times 0 is 0, so that's going to work out, right? Because 0 is equal to 0. All right, numbers that multiply to negative 30 add to a positive 1 are plus 6 and minus 5. And so I can just flip the signs for the other two, negative 6 and positive 5. All right, I think the next one is on multiplicity, so I'm going to stop this one, but Take a look at the next one after this.